So what we did Friday was systems of equations with two variables. What we're doing today is systems of equations with three variables. Now, we can use substitution with three variables, but it's not the preferred method because it does get a little funky because we have to substitute one variable into the other two equations and then go from there. And the main goal is to solve for each of the values. Now, we're not going to actually solve this first one here. I kind of got ahead of myself. What we're doing here is the same as what we did at the start of Friday. They're going to give us an ordered pair. Here, 3, negative 5, 1. And we need to check and see if it works for all three equations. If it does, then it is a solution. If it doesn't, then it is not. And just like with Friday, so here, 3, negative 5, 1. If it doesn't work for one of the three equations, it doesn't work. It is not a solution to the system. So if it fails for one, we don't have to check it for the others. It's just done. So we could start off with the first equation. 2 times x plus y minus 3 times z. And we plug in our x, y, and z values. Now we could do this by hand, or we can take all this and plug it straight into the calculator. So we can say 2 times 3 plus negative 5 minus 3 times 1. And we get negative 2. So it works with the first equation. Then we can move on to the second and plug x, y, z in. And do the exact same thing and see if we get 24. We can say 3 minus 4 times negative 5 plus 1. And it is indeed 24. And that brings us to the last equation, negative 3 times 3 minus negative 5 plus 4 times 1 is equal to 0. And again, we can plug this onto the calculator. We can say negative 3 times 3 minus negative 5 plus 4 times 1 is 0. And since the point 3, negative 5, 1 worked for all three equations, yes, it is a solution. It is a solution to the system. Any questions on this first one here? And we could do this again with B. So we can plug the point 2, negative 3, 1 into each one of these here. So for the first one, we'd say 2 times 2 plus negative 3 minus 3 times 1 is equal to negative 2. We can pull the calculator back up and say 2 times 2 plus negative 3 minus 3 times 1. And we get negative 2. So negative 2 is equal to negative 2. Okay, so it works for the first one. Then we can move on to the second and say 2 minus 4 times negative 3 plus 1 is equal to 24. And in the calculator, we can say 2 minus 4 4 times negative 3 plus 1 is 15. Well, 15 is not equal to 24, so this is not a solution to the system. It's not a solution to the system of equations. It is a solution to the first equation, but not to all three. So it's not a solution, just like with our two variable. It has to work for all three. And at this point here, we don't even have to try the third, because if it fails for one, we're done. Any questions on these here? Solving the system of equations with three variables. There's different methods to doing this, and that's what I was kind of getting to earlier, but the main one that is used for solving these systems is elimination. We solve it by elimination. Now to do that, we look at all three and we pick a variable to be the first one that we eliminate. And we eliminate that variable out of all three equations. Then we pick another one and eliminate it out, leaving us with one, and then work our way back. So the first thing we do, especially with three variable systems of equations, is we pick x, y, or z to be eliminated first. And whenever I pick that variable that I'm going to eliminate first, I see which one is going to be easier to work with. And for this here, I would either pick y. Well, apparently I'm going to scroll. I would pick y or I would pick z. And the reason I pick y or z is because z, for this first equation, to get them to be the same, I can easily turn it into 2z or 3z with just one multiplication. I don't have to multiply or change two things. Y is the same way. With this middle equation, I can turn y into 2y or y into 3y very easily. Now, if we chose x, well, getting 3 into 5 or 3b4 is not going to be an easy move. We can do it, but I have to change both the 3x and 4x, or 3x and 5x. I've got to do two multiplications to get them to be the same. And for this equation here, or this setup here, I'm just going to pick z to be eliminated first. Now we need an eliminator equation, one that we're going to eliminate the z's out of the other two. And I'm going to pick the first equation to be the eliminator equation. Now our other two equations, 5x plus y minus 2z, we can rewrite. And the reason I can just rewrite them is because since the first equation, the value in front of z is just 1, I only need to manipulate it to get z's to cancel. If we'd have done x, we would have to change both the eliminator equation and these two here to get them to be the same. Now for the one on the left, to get the z's to be the same, I need to multiply this equation by 2. So we can do 2 times 3x minus 2y plus z equals r2 times 2. Now on the left-hand side, we can distribute the 2. 2 times 3x is 6x. 2 times 2y is 4y. 2 times z is 2z. It's equal to 4. And we can put this equation underneath the first one. Now some books would say that we need to multiply it by -2 to get them to be the exact same, but this still works just fine. Now we can go on and simplify this here. Since the signs are opposite, we will add. If the signs are the same, we subtract. So if we add this here, 5x plus 6x is 11x. Y plus -4y, or y minus 4y is -3y. -2 plus 2 is 0. is equal to 5. So far we've taken two of the equations, added them together, and now have one equation with two variables. We've gotten rid of z. We'll do the exact same thing with our other equation. But this time, to get the z's to be the same, we need to multiply our eliminator equation by 3. On either side. And 3 times 3x is going to be 9x. 3 times negative 2y is negative 6y. 3 times z is plus 3z is equal to 6. So we can put our 9x minus 6y plus 3z is equal to 6 under the other equation. And this time, because our z's have the same sign, we will subtract. Now, I'm trying to keep that straight between addition and subtraction. You want to just make sure to actually do the calculation and not just assume that the variable that we want to eliminate will eliminate. Will cancel out, will become 0. Because if we'd have put, say, plus, well, 3z plus 3z, 3 plus 3 is 6. It's not 0 that we want. 3 minus 3 is 0. So if we actually do the calculation and check, it'll guarantee that we do have the correct operation. We can do the same thing with the rest, going and subtracting. 4x minus 9x. 4 minus 9 is going to give us negative 5. 3y minus negative 6y. The negative and negative would make a plus. Negative 3 plus 6y is going to be plus 3y. And as we've seen already, 3z minus 3z is indeed 0. And lastly, 7 minus 6 is 1. So we've taken 3 equations with 3 variables. Now we have 2 equations with 2 variables. Now we want to do this again to get 1 equation with 1 variable. Now looking at our last 2 variables, which one do we want to eliminate next? X or Y? Well, there's one. Y is nice because it's already 3y in both cases. In some cases, we will have this setup where we don't have to change either equation. Now looking at this here, would we add or subtract the 2 equations from each other? Add. Because negative 3 plus 3 is the same as 3 minus 3, which is 0, which is exactly what we want. So we can add the rest. 11x plus negative 5x. 11 minus 5 is 6x. 5 plus 5 is 10. Well, now we have 1 equation with 1 variable, so we're going to solve. And we can solve it by dividing both sides by 6, telling us x is equal to, almost, because it'd be 10 over 6, which is not 5/2. It is 5/3.
Your bottom problem has a 5.
Okay. Oh, yes. Thank you. Nope. So it would be 1. That's nice. Thank you. I think I just copied the 5 from the other equation, apparently. Any questions on this here? Now, when we covered this in Algebra 2, I said at this point we would work our way back up. It would be the next step. And all that means is, okay, now we just need to find the other values, because we found x, value of x, is 1. Now we need y and z. Well, we could go through this entire process and work it out so that y is the last one remaining, or, well, I do have two equations here that are just x and y. So what we can do at this point is I can just pick one of those two equations. So I can pick 11x minus 3y. We can do it off to the side here. Equals, make sure I get the correct 5. And we can plug 1 in for x. Then we can solve. Well, 11 times 1 is 11. Minus 3y is equal to 5. Minus 11 from both sides, telling us negative 3y is equal to negative 6. At this point here, we can divide both sides by negative 3, telling us y is 2. Come back up here, plug it in. Now we need to do the same thing for z. Now with z, the last one, we have several different options. We actually have 5 different equations we could use. And it seems weird we say 5 because I have these 3 equations that we could use. I also have this one, and I have this one. We just need to pick one to use. I can use the top one, our 3x minus 2y plus z is equal to 2. I just picked this one mainly because z is 1 and it's positive. Doesn't really matter which one we pick. So we'll have 3 times 1 minus 2 times 2 plus z is equal to 2. 3 times 1 is 3. 2 times 2 is 4. Well, 3 minus 4 is negative 1. Plus z is equal to 2. Plus 1, telling us z is 3. So our solution is, funny enough, the point 1, 2, 3. And we could plug it in any one of these equations if we wanted to check it. Because we could plug it into these here and see if it gives us a true statement. And it will. And that's all we have to do for this here. Questions on any of this here? We kind of remember doing this from Algebra 2. These here are not bad, they're just tedious. They're time consuming. So this one here, it's going to be very helpful to get these equations into a more standard form than what they are. Now the top equation is fine as it is. We have x and y on the one side, our constant term on the other. However, the other two are not in that form. So we can start off with the middle. 3y is equal to 5z minus 12. And we can subtract 5z from both sides, telling us that 3y minus 5z is equal to negative 12. They're going to make us 2. But, all right. And our last equation, 5x, 5 times x plus z is equal to 2z plus 5. Here we can distribute the 5, telling us that 5x plus 5z is equal to 2z plus 5. At this point here, we can subtract 2z from both sides, telling us that 5x plus 3z is equal to 5. So now we do have 3 equations with, funny enough, 2 variables each. 2 of them are in terms of x and y, and one of them is in terms of y and z. Well, sorry. One's in terms of x and y, one of them's in terms of y and z, and the other's in terms of x and z. Now, at this point here, we really just need to pick one equation to eliminate. We could have also done this one in substitution, and this is the funny one where substitution could actually work just fine. But we either need to get them in terms of x and y or x and z or one or the other. Because if we take the top one and want to eliminate x out, we can do that. So for this here, we can eliminate the x's and then have 2 equations with y and z. Or we can eliminate the y's out, the 2 equations that y have. Eliminate it out and have terms of x and z, or one or the other. So here, let's just do x. So the top equation has 2x. This equation has 5x. And the first number that we'll need to get these two to be the same is 10. Because 2 and 5, the first number is 10. So what we have to do is take our top equation, 2x plus y is equal to negative 2, and multiply the whole equation by 5. And if we do this here, 2x times 5 is 10x. 5 times y is plus 5y. And negative 2 times 5 is negative 10. Our other equation here that has 5, we need to multiply the whole thing by 2. 2 times 5x is 10x. 2 times 3z is plus 6z. And 2 times 5 is 10. And now we can put these over the top of each other. 10x plus 5y equals negative 10. And I did leave a little bit of a space so that we can match our variables up, because the other equation, we do have 10x plus 6z is equal to positive 10. We could have lined them up and just had x's over y's, but we do need to make sure that we don't actually combine those because they are not the same. And at this point here, we would subtract, because 10x minus 10x is indeed 0. Questions on this so far? This is a very funky setup. This is one that we definitely didn't do in Algebra 2. Now, 5y minus, well, we don't have any y's, so 5y minus 0y is just 5y. Now we don't have any z's, but we're subtracting what? 6z from it, so it should be negative 6z, because we're subtracting it from that equation. Does that make sense? It'd be very tempting to want to put plus 6z, but since we're minusing it, it has the subtraction sign. And lastly, negative 10 minus 10 is negative 20. Now at this point here, we can't use either one of these two equations because we use both of them to get our 5y minus 6z, yes? The other equation we have is also in y and z, so now we can use these two to eliminate out. Which one do we want to eliminate, y or z? We can do y. But in either case, unlike the last one with these two, the y's are not the same, so we can't just put them on top of each other. So again, with this one here, we need to change both of these so the y values are the same. Well, luckily, in this case, the number we need to multiply both of them by is kind of the number that's already given to us, because the first number that 3 and 5 both go into that we can make the same is 15, which just means we multiply this entire equation by 5, and we multiply this entire equation by 3. And for us here, distributing the 3 times 5y is 15y. 3 times 6z is 18z. And negative 20 times 3 is negative 60. We can do the same thing with our other equation. Distribute the 5. 5 times 3y is 15y. 5 times negative 5z is negative 25z. And negative 12 times 5 is negative 60. Now we can put them over the top of each other. And are we going to add or subtract? Oh, we're going to subtract. Negative 15y minus 15y is 0. Negative 25z minus negative 18z. Well, the negative and negative make a plus. Negative 25 plus 18 is negative 7z. Negative 60 minus negative 60. Well, negative and negative makes a plus, so negative 60 plus 60 is 0. And this seems like it's an issue, but it's really not. Z is 0. If they'd eliminated each other out, Z had also canceled out and we got a false statement, then we would have a problem. Where we got 0 equals 1, that's not a true statement. It is no solution. It is inconsistent. Yes. So we know Z is 0. Now we need to find which other variable we want to find next. X or Y. We can do X. Now we have several different options. Because I could pick this equation here, or this one, not that one. This one here. We can use any of these equations here to find X or Y. Well, this one's kind of nice. Y is already on one side, Z is on the other. We don't have to do a whole lot to solve. So 3y equals 5z minus 12. 5 times z minus 12. And if we plug the value of z in, 5 times 0 is 0, just giving us so y is -4. Questions on how we found y or z? Now we just need to find x, yes? Now there's several, again, different equations we could pick. Well, I can pick the 5x plus 3z equals 5. We could have picked any of the equations that just had x, y, y, z, any of them that had x, y, and z, or any combination of those two. I picked this one here mainly because the value of z is 0. 3 times 0 is 0, telling us 5x equals 5. We divide both sides by 5, telling us x is 1. So our solution for this is 1, -4, 0. And we could plug this into our original 3 equations, and it will give us a true solution every single time. Yeah. Any questions on this here? I have a feeling that the book would tell you to do this by substitution, because we could get the middle equation, get y by itself, by dividing by 3, plugging it in and solving from there, or doing it with x. But again, there's different ways to get at it. Determine the number of solutions to the system. State whether the solution is inconsistent or the equations are dependent, and write a solution. So, looking at this here, we need to determine if we want to eliminate x, y, or z first. Because before we can answer any of the questions, we do need to solve it. And looking at these 3 here, which variable does it look like is going to be easy to eliminate first? X, because it does have a 1 in front of it. Because whichever variable has a 1 in front, positive or negative, is going to be the easier one to work with. Now, which one of these 2 do we want to be the eliminator? The top or middle? Top. And all that means is that's going to be the one we eliminate everything out of. So we can start off by writing our other 2 equations. And again, the reason we can do this is because since our eliminator equations, number in front of x is 1, we don't have to change the other 2 equations. Now, what's really nice for us is since the top one and the middle number in front of x are already the same, I don't have to do anything to it for us to be able to eliminate x. Now, since the signs are opposite, we can just add these 2 equations together. X plus negative x, 1 plus negative 1, is indeed 0. Negative 2 plus 6y, negative 2y plus 6y, 6 minus 2 is 4, so we have 4y. 2z plus negative 3z, 2 minus 3 is negative 1z. And lastly, 3 plus negative 8 is negative 5. Now the other equation, we can't just put it there like we did on the other one. We are actually going to have to multiply our negative x plus 6y minus 3z equals negative 8 by a scalar for the x's to eliminate. And what would we multiply it by? We'd multiply the whole thing by 3. 3 times negative x is going to be negative 3x. 3 times 6y is going to be plus 18y. 3 times negative 3z is going to be negative 9z. 8 times negative 3 is negative 24. And again, since the signs in front of x are opposite, we're going to add 3x plus negative 3x. 3 minus 3 is indeed 0. 2y plus 18y is 20y. 4z plus negative 9z. 4 minus 9 is negative 5z. And lastly, negative 6 plus negative 24 is negative 30. Now, unfortunately, at this point here, we're going to have to change the value of one of the two variables to get another one to cancel. Which one do we want to eliminate next, y or z? Z. So when we look at this here to changing the variables, we always want to go up. Now, since the number in front of z is 1, our other equation, 20, y minus 5z equals negative 30, can remain the same. Because we can multiply by 1z and get to 5z easily. Now what we're going to have to multiply our 4y minus z equals negative 5 by is, well, 5. 5 times 4y is 20y. 5 times negative z is negative 5z. And then 5 times negative 5 is negative 25. So we get 20y minus 5z equals negative 25. Now, since the signs for z are the same, would we add or subtract? Subtract. And we could try it with this here, negative 5 minus negative 5. Then, yep. Negative and negative would make a plus. So this would cancel, so we would end up subtracting across all of them, yes? 20 minus 20 is also 0. On the other side, the negative and negative make a plus. Negative 30 plus 25 is negative 5. Is this true? No. So determine other solutions. Well, how many solutions do we have? 0, because this is no solution. And the system would be inconsistent. And the solution set in Alex would be the empty set. There's going to be an option that looks like that. There's just 2 brackets with nothing in the middle. Realistically, we would put a 0 with a line through it is the empty set. Whenever we talk about sets, we put a brace, 0 with a line through it, brace. This is considered the empty set. This is also why some teachers don't like you using 0 with a line through it or writing it as this, because that's not 0, that is the empty set. But that would be it. That would be the empty set for this here. Questions on any of this here? And we will go over how to do these in the calculator and use matrices to be able to solve these. Now, we are not done with the note sheets for this here, but we're going to finish these tomorrow.
I was kind of scared because I thought it was.